All right, hi everybody. We're working through the trigonometry review here. This is question 6. It says the hypotenuse of a right triangle has a length of 10. Determine its maximum possible area. Okay, now we could have done something like this before using like the Pythagorean theorem and setting this up, but actually trigonometry makes this a fair bit easier. Okay, here's my right angle triangle. Here's, let's say, x, that's my base. Here's y. Okay, that's maybe the height here. And I know that the hypotenuse is 10. Okay, let me write that out a little nicer. 10. Now, what I'm going to do here is I'm going to make this angle here theta. Now, what that does for me is I know, for example, that the cosine of theta is going to be equal to x over 10. And that tells me that x is equal to 10 cos theta. And I know that sine of theta is going to equal y over 10, which means y is equal to 10 sine of theta. Okay? Now, I want to determine the maximum possible area. Well, area is going to equal x times y, in this case, divided by 2. Basically, 1/2 base times height. So, let's plug in what we know. Well, I know that x is going to be 10 cosine of theta, and I know that y is going to be 10 sine of theta all over 2. Okay? Well, let's take a look at this expression. Let's just simplify some stuff here. This is going to be 10 times 10 is 100. Divided by 2 is 50. So this is going to be 50 sine of theta cosine of theta. But remember that 50 is going to be 2 times 25. So 25 times 2 sine theta cos theta. Now the reason why I do that is because 2 sine theta cos theta, that is an identity. That is equal to the sine of 2 theta. So what I've done here is I've taken the expression for area and I've written it down in terms of theta, but a nice simplified expression in terms of theta. Now, to maximize area, I will take the derivative with respect to theta. And that will end up being 50 cosine of 2 theta. Okay, to determine the angle that provides us the maximum value, okay, I'm going to set this equal to 0. Now divide by 50. Get me 0. That's not going to change anything. Now cosine goes to 0. The first time that goes to 0 is when the angle inside it goes to pi over 2. So 2 pi would have to equal pi over 2 for this to work. And really, we could consider a general solution here, but it doesn't make any sense because we're dealing with this triangle right here. The largest angle this could possibly be, I mean, the upper bound to that value is pi over 2. So this is fine here. When you divide by 2, we're going to get that theta is equal to pi over 4. And so now, therefore, the area is going to equal 25 times the sine of 2 times pi over 4. Pi over 4 is the angle that maximizes this area here. 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. So the answer is 25 units squared, just centimeters squared, whatever that turns out to be, centimeters squared.